All right, good morning or afternoon, whenever you're watching this. So we are in statistics week 5, histogram and box plots. The objective for this week, students will be able to will be able to order data set from least to greatest, make a frequency table from the data set with evenly spaced intervals, and graph those frequency tables. Students will also be able to construct n plot box plots from a data set. So the vocabulary for this week, histogram and box plot. So a histogram is basically just a bar graph, but instead of the little actual bars being separated, they're actually all huddled together. It's a bar graph that is used to display the frequency of data divided into equal intervals. This equal intervals part is actually really important. The bars must be of equal widths and should touch but not overlap. The height of the bars indicate the frequency of the data values within each interval. That may not mean much to you right now, but I'm going to go into what that means and what that looks like. Uh, a box plot is another way of displaying information. It can be used to show how the values in the data set are distributed. You need to identify the box plot, 5 values to make the box plot. The 5 values that you're going to be finding are the minimum, the quartile 1, quartile 2, quartile 3, and maximum. If those three terms look familiar to you, they should. They are the terms from the mean median mode week. I believe that was week either 2 or 3. So hopefully you guys remember what that was about. Okay, so creating a histogram. Step 1, order your data set from least to greatest. So listed are the ages of students in a math classroom. The data set ranges from 18, 18, 19, 19, 19, 20, 21, 21, 21, 22, 22, 23, 24, 24, and 24. That's a total of about 15 numbers there. So what I mean by even intervals, what we're going to want to strive for is we're going to want to strive for intervals that are as close to each other as possible. Now, right here under step 2, right, I have create a frequency table. Since the data ranges from 18 to 24, the range is 6. What I did there was I took the maximum number, 24, and I subtracted the minimum number, 18, and that gave me a range of 6. If you guys remember, this is your range. You guys found this like 2 weeks ago, and what this means is there's a total of about 6 numbers approximately within the data set. You need to split this range into sections that are even to the best of your ability. It's okay for the last category to have a little bit of extra numbers, but we generally want to break them up into even categories. Since there's 6 of them, we want 2 numbers at least to be represented in each section, right? Like there's 2 numbers here, there's 2 numbers here, and there's 2 numbers here. This won't always work all the time. There might be some overlap. It's okay to have a little bit of overlap, like for example, in this section right here. Um, the first one, there's only 2 numbers, 18 and 19. The second one, there's 20 and 21. And the last one, there's 21, there's 22, 23, and 24. So there's technically an extra number there, but that's okay. We try to avoid that for the most part, but sometimes we can't. So what do we do now? Well, what I expect you guys to do is, first of all, order your data set from least to greatest. If you notice, the data set was already in least to greatest form. Then what you're going to want to do is you want to give me the frequency. Now you have your intervals, right? Um, I'm going to count how many numbers are in my data set that fall between 18 and 19. So 1, 2, 3, 4, 5. I count 5 numbers that that are between 18 and 19. That includes 18 and 19. So there's 2 18s and there's 3 19s, so a total of 5 numbers that fall in the age interval of 18 and 19. Okay. The next interval, the numbers are between ages 20 and 21. So that's 1, 2, 3, 4, 4. Okay, there's only 4 numbers. So there's only about 4 numbers that are um, that are there, right? So from here, we need to count the last ones, 22 to 24. So how many numbers are here? Let's see, 1, 2, 3, 4, 5, 6. There's 6. Now, if you notice here, 6 plus 4 plus 5 is 15. Remember in the beginning I said there was about 15 numbers on a data set? Well, that's where I got that from. I counted them, and I can add up my frequency to equal my data set at the same time. Okay, so that's step 1 and step 2 from what I want you to do. You are going to have to do this for the homework and practice of this week, right? You're going to have to order your data set from least to greatest because they're not always going to be in order for you. Then you're going to want to create a simple T-chart like this with with intervals on the left side and frequencies on the right side. Once you have your information organized like this, you can actually move on to plotting your histogram. Okay, so what does that look like? Well, you're going to start with the simple X and Y axis, right? You're going to cross them over, and you're going to want to put the information that you just split off, right? So if you notice here, I have ranges. My intervals are down here. 18 and 19 is down here. 20 and 21 is down here. 22 and 24 is down here. Frequency is my up and down. It's the y-axis, right? Now I know that none of my frequency, like let's go back here, none of these are above 6. So I went up one above it, just to have it there. But really, this is how you graph it. How many, in the category of 18 and 19, what was my frequency? Well, let's go back. My frequency was 5. I'm going to draw it from this point all the way up to 5, right? That is my histogram for 18 and 19. 20 and 21. Okay, how much did I say? Say 20 and 21 is 4. So 20 and 21, I'm going to start here, and then I'm going to go up to 4 like this. Notice how they're touching, right? Like they're not apart like they would be on a normal bar graph. Here, they're actually next to each other. And there's a reason for this. Histograms are mainly used to determine information that is that relies on one another. For example, the next category picks up after when the other one left off. We have 18 and 19, 20 and 21, 22 and 24. It's kind of continuous. Versus a bar graph would be better to graph things like categories, like colors, right? Like red, blue, yellow, whatever, right? Red would be its own category, blue would be a separate thing, and yellow would be a separate thing. That's why those are separated in a bar graph. But in a histogram, like you see here, everything depends on the previous one. Okay, which is why we want them to be as close to each other as possible in terms of the size of the interval. Okay, 22 and 24, we have 6, our frequency of 6. So we're going to take this, and then we're going to go up to 6, going to go here and down. It connects to it. That is my histogram. That's it. The majority of the work that you guys are going to be experiencing is going to be in step 2, when you actually are counting and doing that. Actually, the most tedious part of this is probably step 1, organizing your data from least to greatest. If you are lucky enough and the data is already arranged for you, this doesn't take a lot of time. However, if the data set's all mixed up, you need to arrange it from least to greatest. And yes, some of the examples are going to have a lot of numbers, but you won't have as many problems. Right? I'm going to list the problems at the end. There's going to be fewer, but there is going to be a lot of numbers in them. I just need you to get these steps down, okay? I do want to see your data set in order from least to greatest, right? Step 1. I do want to see your frequency tables in your work. That's step 2. And I do want to see your final drawn histogram labeled with your frequency, whatever your intervals are, and of course, labeled like this. This is your actual histogram. Okay, so now we're going to move on to the next thing that you're going to have to do, which is constructing box plots. Okay, so here for step 1, the same as last time, right? I'm right here. You're going to want to arrange from least to greatest. Your data set, as shown here, I have 2, 3, 3, 3, 4, 4, 4, 5, 7, 7, 8, 8, 9, 9, 10, 10, 11, 12, 12, and 14. Okay, I'm going to want to arrange these 20 numbers into from least to greatest. Now, I've already done that for you. They were originally mixed up, but in your problems, they're going to be mixed up. So you're going to have to just arrange them from least to greatest. Don't forget to do that, right? The next step, identify 5 key values. I need to identify what our minimum is, our quartile 1, quartile 2, quartile 3, and our maximum. If you can remember from about 2 weeks ago, your quartile 2 is basically your median. It's another word for median, or the number physically in the middle of all your data set. Problem. There is 2 numbers sharing my quartile 2. So how am I going to resolve this? Well, I'm going to take both numbers, 7 plus 8, and then I'm going to divide them by 2. 7 plus 8 is going to be 15, and then 15 divided by 2 means my quartile 2 is going to be 7.5. Okay, we're going to save that for later. Right? Now, remember what I said, whenever you're trying to figure out your quartile 1 and quartile 3, your quartile 1 is going to depend on everything to the left of your quartile 2, and your quartile 3 is going to depend on everything to the right of it, right? So here we have, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice something here. I'm going to draw a line right there. 7.5 is actually in between 7 and 8, which means that what I just did here is technically incorrect. Let me go back. Right. There you go. Okay. Because quartile 2 is technically in the middle. So that 8 belongs to the right side, and that 7 belongs to the left side. Okay. So when we're figuring out quartile 3, if you notice, there's 2 8s, right? 1, 2, 3, 4. There's 4 numbers. 1, 2, 3, 4. 4 numbers. And then there's, again, these 2 numbers that are in the middle. So how am I going to resolve this? Again, I'm going to take both numbers. I'm going to add them up. Then I'm going to divide them by 2. Now, if you ever run into the same number, you add them up and you divide them by 2, you're going to end up with the same number. Quartile 3 is just 10. Your maximum is your largest number. There's no extra step there. Your minimum is your smallest number, right there. Again, quartile 2, let's see, there's 1, 2, 3, 4 numbers to the left of the center. 1, 2, 3, and 4 numbers to the right. So as you can see, there's 2 numbers vying for the middle again, but this time, since they're the same numbers, like I did before, we're going to end up with the same number. Right there. Right there. Okay, so that is what I mean by identifying the key values, right? I know what my minimum is now. I know what my quartile 1 is. I know what my quartile 2 is. I know what my quartile 3 is, and my maximum. Okay, so what do I do now? If you notice, there is a number line, right? And it has values from 2 to 16 already plotted on there. You're going to have to draw your own number line, right? And then I want you to plot all 5 of those key values. So I'm going to put a dot above the 2. I'm going to put a dot above the 4. I'm going to put a dot above 7.5. Now, 7.5 is somewhere in the middle of these two, right? I'm going to guess that it's right there, right? Because this is 7 and 7.5 would be right there. Let's see, what's 10 would be the next one. And then 14 would be my maximum. Okay, so now that I have all 5 of them plotted, I need to draw a box around quartile 1, quartile 2, quartile 3, okay? So here I'm going to do this. Then I'm going to draw a line through the middle, which is my quartile 2. Then I'm going to connect the edges. And another name for this is a box and whisker plot. But that's pretty much it. That's all I want you to do. Here, you would label. You don't necessarily need to label these like this in your homework. I mean, you can if it helps you remember. It's just to help you reinforce where everything goes. Because during the quizzes, I might just put one of these and you need to be able to point out. If I just give you a finished graph like this and I ask you what are my key values, you should be able to know where the minimum, maximum quartile 1, 2, and 3 is by just looking at the graph. So you should be able to do this forwards and you should be able to do this backwards. They're easy points on a quiz if you can remember how to do these things, okay? Let's see. The homework and practice for this week should be numbers 5 through 8, as well as 13 through 18. These numbers are your box plots problems, and these are your histogram problem. Right, so not a lot of work this week, but that's intentional by design because 5 through 8 are going to be very tedious, but I need you to know the steps to do them so that when you guys go into the quizzes, you know exactly what to do. And the histograms are going to be worth quite a few points. Box plots are also going to be worth points, but again, they're going to be mostly used for you need to know them forwards, and you need to know the box plots, how to get the information backwards as well. Okay, so good luck. Join me for my new Zoom hour. So Zoom, I believe, is from 1:30 p.m. to 2:30 p.m. I'll put up a link on the Google Classroom. Make sure to join that. And I don't think there's anything else. If you have any questions, join the Zoom hours. Hopefully these hours are a little better for you guys. This is based off of the feedback. I know if all the teachers are going to be on this particular hour, so I'm going to be doing this from Monday to Thursday. All right, guys, good luck. Make sure you're logging into your daily, make sure you're logging into daily everything and training your notes as well as the homework and practice. Good luck this week.